Welcome back. We're still in section 5.1. We're still talking about simplifying. Have those trig identities out and ready to go because we'll be looking at those as we go through. We're still talking about simplifying. So you kind of want to look and see what you have. I can't factor anything out here, but I can rewrite. And I have that cotangent. So what I can do is I can put sine of t plus, now cotangent is the same as cosine t over the sine of t plus, times, the cosine of t. So what that gives me is the sine of t plus cosine squared t over sine of t. In order to add fractions, we need a common denominator. Our common denominator is just going to be the sine of t. So we're going to multiply by sine t over the sine of t. We're just multiplying by 1, not changing anything. So we end up with sine squared t over the sine of t plus cosine squared t over the sine of t. Now, when we add those, our common denominator stays the sine of t. Sine squared t plus cosine squared t over the sine of t. Now, if you look at your Pythagorean identities, sine squared theta plus cosine squared theta is 1. So all that we can rewrite as 1 over the sine of t. All that just became 1 over the sine of t. Let me rewrite that. Sine t. All right, let's look at another one. Once again, it's all about getting that feel of rewriting. Cosecant, I'm going to rewrite that. That's the same as 1 over the sine of x minus the cosine of x. And now cotangent is the same as cosine of x over the sine of x. So that gives me the sine of x minus cosine squared x over the sine of x. What's nice about this one, we already have a common denominator. We get 1 minus cosine squared x over the sine of x. Don't forget your Pythagorean identities. Sine squared x plus cosine squared x equals 1. Now, if I subtract cosine squared x from both sides, I get sine squared x equals 1 minus the cosine squared of x. So I can replace 1 minus cosine squared x with sine squared x over the sine of x. Keep in mind, sine squared is just sine of x times sine of x. And that's over the sine of x. Now, one of the signs on the top and on the bottom cancel out, so all that equals just sine of x. It's all about being able to rewrite for these. That's what I think is the fun part. It's kind of like a little puzzle. All right, a little bit more difficult here. Now, what we need to get is a common denominator to add these fractions. So I'm going to multiply the first fraction by sine theta over sine theta, 1 plus cosine theta, 1 plus cosine theta. So we get sine squared theta over sine theta 1 plus cosine theta. Plus, we get, now I'm going to distribute the cosine. We get cosine theta plus cosine squared theta over sine theta 1 plus cosine theta. So now I'm going to add my numerators. I'm going to rewrite as well. Sine squared theta plus, I'm going to put the cosine squared first, plus cosine theta over sine theta 1 plus cosine theta. I'm just going to hold off on rewriting the denominator for now to see if I can get away with not having to do it. Now, if you look and remember your Pythagorean identities, you see how we have on the top sine squared theta plus cosine squared theta? Looking at our Pythagorean identities, that's just 1. So we end up with 1 plus cosine theta over sine theta times 1 plus cosine theta. Now, if you look, 1 plus cosine theta is on the top and on the bottom. They cancel out. In the end, we're left with just 1 over the sine of theta. And there is our answer. B, to get that common denominator, multiply by 1 minus sine theta. 1 minus sine theta for the first fraction. 1 plus sine theta. 1 plus sine theta. Now I'm going to multiply these out. So I have 1 minus sine theta. And now when I multiply 1 minus sine theta times 1 plus sine theta, they're conjugates. So when I multiply them, I get 1 plus sine theta minus sine theta minus sine squared theta. So when I multiply them, I end up with 1 minus sine squared theta. That's my denominator. 1 plus sine theta over 1 minus sine squared theta. So now I end up with 1 minus sine theta plus 1 plus sine theta over 1 minus sine squared theta. On the top, my sine of thetas cancel out. So we're left with 2 over 1 minus sine squared. That looks pretty familiar. My Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Now, if I want to get 1 in sine on the same side, I subtract sine squared theta from both sides. I get that cosine squared theta equals 1 minus sine squared theta. So instead of writing 1 minus sine squared theta, I can write 2 over cosine squared theta. Now that's the same as 2 times 1 over the cosine squared theta. 1 over cosine is the secant. So it's 2 secant squared theta. That's our simplified value. Now let's rewrite problem number 7. We want to get rid of the fraction. Now, if you notice, we have 1 plus sine theta. If you look at the last problem we did, where we multiplied those conjugates, we ended up with 1 minus sine squared theta, which equaled, in the end, cosine squared theta. So one of the ways to get rid of the denominator is to multiply by the conjugate. So it's 1 over 1 plus sine x. So the conjugate, 1 minus sine of x. So what that gives us is 1 minus sine of x over 1 minus sine squared of x. We just did this in the last problem. And as we saw above, instead of writing 1 minus sine squared of x, we can put cosine squared. So we'd end up with 1 minus the sine of x over the cosine squared of x. Okay, now, what we can do, it's the same as 1 minus sine of x times 1 over the cosine squared of x. So it just says get it so it's not a fraction. So what I can do is I can write 1 minus the sine of x. And instead of writing 1 over cosine squared, secant squared x. And there it is. We're going to see the need for this later on in the chapter. For right now, it's just an exercise of being able to rewrite and manipulate these trigonometric expressions. Let's go to the next page. We're going to do the same thing. We're going to rewrite so it's not a fraction. When you see something like that, we have cosine squared of x minus 4 over cosine of x minus 2. Now, there's a couple of different ways to do this. Cosine squared x minus 4, if I make cosine of x equal to y, what we'd end up with is y squared minus 4, which is y plus 2, y minus 2. So looking at this one, it's a little bit easier, actually. It's the cosine of x plus 2 times the cosine of x minus 2 all over the cosine of x minus 2. Cosine of x minus 2 on top, and on the bottom, they cancel each other out. We have no more fraction. Cosine of x plus 2. And there we go. It was actually quite a bit easier than it may have been otherwise. We kind of want to learn some different techniques as we're going through. All right, so what we're going to do is we're going to use substitution when x equals the tangent theta to rewrite. Now they're telling us that theta is between 0 and pi over 2. So we're in quadrant 1. Keep in mind they're all positive in quadrant 1. So when we rewrite this, what we have is the square root of 4 minus 2 tangent theta squared. Square root of 4 minus, and we square the 2 tangent theta, we square the 2 and the tangent. So we get 4 tangent squared theta. All right. What we can do now, we can factor out of 4. So it becomes 4 times 1 minus tangent squared theta. That looks a lot like one of our Pythagorean identities. 1 plus tangent squared theta. Oh, excuse me, that's a plus, sorry. 1 plus tangent squared theta equals secant squared theta. So instead of writing 1 plus tangent squared, I can write secant squared. So it's the square root of 4 times secant squared of theta. Using our properties of radicals. The product property, the square root of 4 and the square root of secant squared theta. We end up with 4, which is 2, secant squared theta. Remember, when we solve, we get 2 solutions. Because we're looking at quadrant 1, we're going to keep the positive, so it's just 2 secant theta. That might change if we were in a different quadrant, but because we're in quadrant 1, keep it a positive. Let's try another one like that. Once again, theta is between 0 and pi over 2, so we're in quadrant 1. Square root, 25 minus 5 sine theta, and we're squaring that. 25, square the 5 and the sine, so it's 25 sine squared theta. You can factor out of 25, so 25 times 1 minus sine squared theta. Keep those Pythagorean identities there. Sine squared theta plus cosine squared theta equals 1. So to get the 1 and the sine squared on the same side, subtract sine squared theta from both sides. So we get the cosine squared of theta equals 1 minus sine squared theta. So we end up with the square root of 25, and we'll replace 1 minus sine squared with cosine squared theta. Then we just take the square root of both, square root of 25, square root of cosine squared theta. 5 cosine theta. Keep it positive because we're in quadrant 1, and there we go. All right. Like I said, we'll be doing more practice with these as we go through, and it's all going to lead us into a final goal of rewriting, and also when we get to solving these trigonometric equations. Thank you, and I'll see you in the next video.